Hi, good morning, everyone. I'm Vanessa from the Strategic Outreach and Development team in NSCC. A very warm welcome to our second enablement session organized by National Supercomputing Centre Singapore. Thank you to those who had previously attended our inaugural session on 9 September. We were blessed with an overwhelming response of 200 attendees. Today, we are very honored to be able to invite international speakers for our session, where they will cover non-technical domains such as social sciences, economics, law, and finance. We have Mr. Mawel from Union Bank Philippines, Prof. Duan from NUS Credit Research Initiative, Dr. Stefan from AISG, Dr. Prasanta from IHPC ASA, Mr. Karthik from MSc Hexagon, and lastly, Mr. Nicholas from NVIDIA. Today will be an exciting session for sure. The agenda today will be as follows. Our speakers will present first before they answer your question at the end of the session. Feel free to submit your questions here on Zoom via the Q&A function at the bottom of your screen. Our speakers will try their best to answer them. Without further ado, let's welcome Mr. Bernard Tan, Director of Strategy Planning and Engagement of NSCC, to share more about NSCC and Aspire One. Bernard.
Hi, good morning, everyone. Before that, just want to ask my boss, Prof. Tan, if he has any other things he'd like to share with the participants in schools.
Thank you so much, Bernard. My name is Tan Tin Wee, and I'm the Chief Executive of the National Supercomputing Centre of Singapore. And we're really appreciative for not just the speakers, but also all of you now that we've opened it up to all our speakers to come on, participants to come on board. Let me warmly welcome all of you participants to this second engagements enablement webinar that we have put together. As you can see from the incredible range of outstanding speakers that we have lined up for you. We hope that you will have a lot of wonderful learning experience, not just in your own area, but also to be aware of what's happening in other fields. NSCC is funded by the National Research Foundation in order to build a national computational research infrastructure that will be able to support your research as it accelerates into the future, and to ensure that all of us will have easy access to these resources, notwithstanding this COVID period that we are struggling through. And in this regard, I'd like to thank all of you for taking time off your busy schedule and Zoom fatigue to join us in this Zoom webinar to learn something new, to learn something special from our illustrious speakers that we have assembled for you. Over to you, Bernard.
Thank you, Prof. Tan. Well, good morning, everyone, and really thank you for your precious time. We are very excited to bring you this series of enablement. This is not just going to be a one-off. In actual fact, this is a series of education and training for IHL that we would like to partner you through your journey itself. So beyond today's session, we will also be contacting your IHL's point of contact to really discuss about deep learning courses that you can nominate. We'll be sharing with you competition framework that your school can embark on. But more importantly, there will be a call for educational projects that's coming up from NSCC. And we do hope that with this enablement and you would like to explore more, you can actually set up trial accounts and thereafter apply for HPC resources that you could actually use for your upcoming call for education project that you can explore in the field of either CFD or even AI and many other ways that you can leverage on the supercomputer. As Prof. Tan mentioned, we are very honored to have 6 experts. First off is we have Prof. Duan, who is the Professor for Finance and also the Executive Director Designate for the Asian Institute of Digital Finance at NUS. We have Dr. Stefan Winkler, very important person. He's the Senior Deputy Director at AI Singapore, as well as Associate Professor Practice at NUS itself. So as you all know, AI Singapore helps to anchor deep national capabilities in AI And its objective is to create social economic impacts, grow talent, build ecosystem. And that's very critical for our Singapore. And I believe a lot of the schools have already expressed lots of interest in AI. Next up, we have Dr. Prasada, from research scientist with with the Social and Cognitive Computing Department at the Institute of High Performance Computing at A-Star. So it is very, he's actually a very good scientist that works on network science and behavioral analytics. And feel free to chat up with him if you need some advice on all this as well. We have Mr. Marwell. Okay, he's a data scientist and a digital technology evangelist with Union Bank of the Philippines. And he has 18 years of experience in software and R&D and data AI as well. So privileged to have him. Next up, we have Khatib, and he is our experimental and computational fluid dynamics from Hexagon itself, and specialized in the area of high-speed flow aerodynamics. Okay, so he has been a good partner to NSCC in presenting a lot of our events. Next up, we have Nicolas Walker, who is from NVIDIA. As you know, NVIDIA is one of the leaders in AI solution. So he's the senior solution architect, and he looks after Southeast Asia customers that's around data center, workstation in the areas of HP, deep learning, visualization, and professional graphics. So he's actually on the ground working with a lot of customers. Now, before we kick off, I just want to have a very quick opportunity to set this platform. Now, as you know, COVID has done what many officials and CEOs and CTOs has had to do, and that is to really accelerate digitalization. Now, government officials and business executives all have vital roles to play in guiding their country and organization to function effectively through this crisis itself. The scale and impact poses a real threat to a nation's survival and business continuity everywhere. So it is significant. So it has also significantly impacted every aspect of our life, from a nation's competitive advantage to the economic issues, financial system, to even social and everyday life. It has reshaped the world as we know it. So the speed and the need to digitalize a nation, a business, has gathered greater momentum and urgency. It is so ironic that we are all here today doing Zoom versus a face-to-face meeting, because this is how the new norm is going to be. So it is vital that all our government agencies, local enterprises, IHL, leverage on technologies like HPC, AI, CFD, to really help us achieve innovation and agility, which will give us the new norm on that basis. Now, very quickly, HPC, or high performance computing, as you all know, is the ability to process data and perform complex calculation at high speed. Okay. Now, it is important to note that it is through data that groundbreaking scientific discovery are made, game-changing innovation are fueled, and quality of life is improved for billions of people around the world. So HPC, or high performance computing, is the foundation for scientific, industrial, and societal advancement on that basis. So to keep a step ahead of competition organization, we need lightning speed and high reliable IT infrastructure to process, store, and analyze massive amount of data. So HPC is the foundation enabler to allow a nation, a company, and an individual to achieve scientific breakthrough to solve complex issues and challenges as well. Now, it is my pleasure now to share with you a bit about NSCC. So allow me to share my screen now. Okay, I hope everyone can see my screen. Okay, so very quickly, I'll try to summarize this as fast as I could so that I can give more time to the researchers, so the speakers, to actually allow to share their point of view and some of the use cases. So NSCC is funded by NRF, as what Prof. Tan has mentioned, in providing supercomputing resources, and is a horizontal enabling platform. Okay, it is a national level resource open to all initiative, IHL RIs, and we also have a high-speed network for HPC that is connected via dark fiber, or what we call InfiniBand. So it is the Singapore's first national petascale facility on that basis. Our founding stakeholders are ASA, NUS, NTU, SUTD, and we have also new stakeholders. There's TCOMS and NEA under Medical Service Singapore itself. So as mentioned, we are funded under NRF through the NRI scheme, but at the same time, we are hosted and managed by under A-STAR, as you can see. Moving along, we have a esteemed, brilliant steering committee that covers from all the academic as well as all the industry leaders as well. Our steering committee is actually chaired by Mr. Peter Ho, which is the ex-civil service head. And we also have connections to international supercomputing centers such as RIKEN, which is headed by Professor Satoshi. And and we have a great MOU with them to actually do a lot of collaboration as well, including to US through Professor William Goop. Now, very quickly, our current system is actually Aspire 1, which is 1 petaflop system with 13 bytes of storage and with InfiniBand interconnection itself. Now, we also claim to have one of the highest operational supercomputer in the world. If you are not aware, our supercomputers are actually situated at Fusionopolis on the 17th floor, okay, which is amazing. We are using warm water as the cooling, and also we have digital twin enabled data center itself. Supporting Aspire 1, we also have Aspire 1 Plus system, which is also the HTC system, and as well as a Copen system, which is now supporting NEA on its weather forecasting. Now, in development, currently, which will be ready next year, is Aspire 2, which will ramp up to 10 to 20 petaflops. And this is a perfect time we are doing this enablement, so you actually get to know our system, also the use case with all the application, and in preparation, you can look forward to using our Aspire 2 in the future as well. Okay, and this is a more detailed look into our Aspire 1 system. We have 31,000 core itself. Okay, I'm not going to go into that, but for those actually very interested in AI, do take note, we do have 6 DGX NVIDIA system, so you can leverage on really high AI system itself. Okay, now Aspire 1 NSCC data meets various software. So we actually built on Linux operating system, and we are based on a job scheduler, so it's on a queue basis. And we have various sets of software application. So if you are looking to actually use certain level of software, please contact us. We'll be more than happy to collaborate with you to understand your software stack and on the needs on that basis, so that we can actually work together with you to see how we could start to operationalize and use our supercomputer on that basis. Okay. But most of the common software such as OpenFOAM or PyTorch, all these has been commonly used on our system. Okay, now as you can see, as I said, our unique cooling system is based on really 3: is liquid cooling, air cooling, and chilled water cooling as well. And for our upcoming new system, it will be at NUS I4 building. Okay, and this is where we are looking to build one that has digital twin, IoT sensors, AI assisted, and visualization lab itself. We are ourselves embarking on the new world of technology that we are talking about sensors within our data centers that allow us to track, monitor, and act on any peculiarity as well. Okay. Now, also, we are working very closely with AISG in supporting the national AI platform itself. And this is where, as mentioned, our supercomputers have computational services in the form of 48 NVIDIA V100 GPUs, as well as the DGX, 6 DGX I mentioned to you on that basis. Okay, so especially we have actually did one round of discussion with ORHL, and I believe AI is one of the hottest topic on that basis. And later on, we will have Professor Stefan Winkler to share more about AISG and some of the projects that they have embarked on. Okay, so for some of you, you may be wondering what other projects supercomputer are used for. And this is one of the case example that it is what we call CAPEN. It's a Cray computer. And this is purely just to work on climate modeling and simulation. Climate modeling has increasingly becoming more important, and it impacts not just on our daily life, it also impacts on our city planning. Example would be how air are flowing through our estate, how rainwater are flowing through so that we do not have floods and things like that. And we have to track all the weather peculiarities that's happening from El Nino to El Nino. And this is where tons of data, really massive amount of data is coming in. And this is where supercomputers are put to good use to do simulation and design to allow policymakers, decision makers, architects, engineers to build and solve complex national issues. Okay, and that allows you not to downscale your problem. With supercomputers, you can really tackle the issues head on, which will then solve a particular issue right at its roots itself. Okay, now as mentioned, together with Single RAN, we actually have a nationwide connectivity through ultra high speed InfiniBand, okay, for data transfer, as you can see on the diagram on the right itself. So these are already in place. In actual fact, if you guys in the future starts to use and you have huge demand for supercomputing and you need a dark fiber connected to your campus and the demand is high, we will be more than happy to talk to you to do a direct link as when the demand arises. So currently we have a direct link to ASA, NUSNTU, and SUTD on that basis. So the objective is to make sure that the users have high-speed link at 100 GPS to our supercomputers and make use of our supercomputers on that basis. Okay. Now, similarly, we are also connected globally. So we can definitely work on national projects, for example, the COVID-19 projects globally. And we are connected to various countries in the West, such as to US, to Europe, to Japan, Hong Kong, New Australia as well. So we are well connected globally on that basis. So with that, I just want to quickly sum up. So after this whole enablement session, we are more than happy to be discussing with you about what you want to do for your schools and for your students, how you want to be enabling them, what do you need in terms of stirring up interest and inspiring a student. We'll be more than happy to discuss with you through call for projects or even looking at your current curriculum that we could discuss to enable you. We'll be having a few announcements very soon about train the trainers. Things will be such programs will be available very soon. Now, for those who are interested, you can actually set up a trial account at this website, and there's a user guide, and you can actually do a self-service. All right. With that, I'm going to end my presentation, and I would like to actually pass this time to our next speaker. All right, Vanessa.
Hi, let's welcome our next speaker, Mr. Mawel from Union Bank, Philippines. Mr. Mawel, please.
Good morning. Let me share my screen. Good morning, Vanessa. Can you see the screen?
Yes, can.
Okay. So, good morning. I trust that everyone is safe and healthy. My name is Marwell, and it is my privilege to be part of this session. As what Bernard mentioned, since the outbreak of COVID-19, we in data science and AI community have been following it closely. The novel coronavirus has crippled society, markets, and economies at an alarming rate globally. This causes us to fire up our data science and AI with high performance computing or HPC tools and start modeling to solve our business problems and even opportunities. The search for positive change and outcomes. Managing the current health crisis is our first priority. Hence, this presentation focuses on understanding data science, AI, for creating HPC solutions, considering short to long-term ripple effects. Because for us, COVID will not go away quickly, but opportunities will. Our world is different. I mean, rules and policies are moving up and down as what we are experiencing right now, especially here in the Philippines. There are limited gatherings, a lot of travel restrictions, hygiene requirements, and even significant focus on protecting high-risk groups. And there are new habits and behaviors that will remain. Remote working while balancing work and life activities, just as today. Surge access to data and AI solutions. Big data, digital channels, technologies and media, and increasing health and wellness concerns. So what do we do now? I think let us turn this crisis into opportunities, and let me share with you how. Let us connect data science, AI with high performance computing tools to our values. As they say, data is the king. As you can see, we start with the use case. Identify our business strategies. What are current challenges? What are strategic opportunities and even priorities? How can we leverage shift in demand to attract our customers and even engagement with using big data and HPC tools? Improving our lenses from products, services, and processes. We must put insights from data science and AI using HPC solutions such as machine learning, deep learning as mentioned a while ago, natural language processing, and computer vision into the hands of decision makers. Let our insights go into decisions, transform our customer experience, and even improve our process. How do we become relevant to the new customer? In times of COVID, they are likely to be inclined to stay at home and have a greater focus on health and wellness. Maybe automatic recommendations or easy identification for fast computing solutions will be a key. How about contactless and low-touch interactions? Automation by replacing high-risk human interactions in service businesses. And lastly, business model reinvention. How do we satisfy the newly unmet needs in terms of customers? Still, in terms of direct-to-customer, big data platforms that needs high-performance computing solution. Let me share with you some. Given this pandemic, we were able to come up with several use cases. A data-driven forecasting models in order to anticipate the changing demand in different factors such as frequency threshold, sales window, weather, holidays, and even the lockdowns that we are experiencing right now. As a result, we've lowered operational costs by improving accuracy forecasts related to demand. As you can see, without HPC, it will take a lot of time to simulate 158 trillion combinations for us to be able to come up with an intelligent model. A cutting-edge AI, deep learning, HPC infrastructures, and even architectures that outperform traditional time series forecasting methodologies. With this, we were able to come up with 97 accuracy in 4 to 8 weeks implementation and even fast iterations. Another use case we leverage on HPC and AI is to augment human capabilities. I mean, unstructured data are hidden across our company and several companies within Asia, even our subsidiaries. We used HPC and AI solutions for credit scoring for potential clients that will yield a better service and product offerings. The previous process, as you can see, used information from PDF, images such as invoices, bills, and contracts that are manually extracted relevant information for their assessment. This process takes around an hour per document, and imagine we're talking about millions of documents to extract and process relevant information. This manual process resulted to challenges such as very time-consuming, a lot of resources doing it daily, a routine activities which is prone to errors, and even incomplete data. As you may have known, human is prone to error. So using AI and deep learning combination with HPC solution, we increased processing volume in terms of turnaround time. We even reduce error rates and boost our productivity. And lastly, we gain additional insights. Without HPC, it's hard to do modeling using, being a technical one, a cascade mask regional convolutional network, wherein you have a high resolution network and HPC backbone. In the last use case that I'm going to discuss with you, we conducted a proof of concept using intelligent process automation, wherein you effectively identify and block various fraudulent activities during verification process and eventually reduce manual operating costs. Using HPC at the end of the day, you can see the deep learning translated from the computer vision in each specific parameters. As you can see, the ID number, given name, surname, and sex, date of birth, from ID recognition, going through liveness detection, and face comparison. So we're talking about 127 gigabytes labeled faces in terms of identifying which database is at risk, which face is at risk. And voila, you have the result, a result with 96% accuracy. At the end of the day, using this solution, we were able to automate our current automating processes and even authenticating the customers without even human intervention. Finally, it is by understanding data science, AI, and HPC benefits that are delivered by the use cases that I mentioned, solutions, and even models, the decisions are taken into reality. I hope through these use cases, because of limited time, I can help you understand a high level of opportunities of leveraging high-performance computing and how they can be put into good use. Use this time to learn more on HPC and create data-driven future. That being said, may you stay safe and healthy. Thank you very much and good morning.
Thank you, Mawel. Attendees, if you have any questions, kindly use the Q&A function below to ask your questions. Mawel will answer them at the end of the session. Next, we have Professor Duan from NUS Credit Research Initiative. Professor Duan, please.
Hello, everybody. You can hear me, right? Okay. So as an old timer, And now when I say old timer, I start up with the computing with punch cards. Okay, that's really old. And so every computer of today is a high performance computer. And so although I say it's a high performance computing, actually to me, it's always in search of higher performance computing. Okay, because my current team has a system, I think it's high performance computing already, but we are still in search of a higher performance computing. Of course, NSCC is a natural choice in my search of higher performance computing. So I'm going to sort of share with you this undertaking. This undertaking is very different from Marwell's description of what they have been doing. What I have is very, very specific, very dedicated, specific task. So let me sort of take you through so you can understand what I'm really saying. Okay. So what I have been doing for past 12 years, I've been a sort of finance trainer, as a finance PhD and so on. But of late, a few years ago, I've been calling myself financial data scientist. But now I'm calling myself digital finance guy. Okay, so, but I go with the time, rebrand myself. The nature of work really is changing too. But the work I'm describing now, it is work I've been doing almost for 12 years now, okay? Single purpose, very systematic approaching it. It's a sort of piece of fintech started 12 years ago. Okay, so what I'm trying to do, or I've been doing, is really to do corporate default prediction. When I say corporate, specifically, we're talking about exchange traded corporate, including all the exchange traded stocks in Philippines or any country in the world. Okay, so that's my definition of a corporate default prediction, because the scope is about exchange traded companies. Later, I will tell you the number. In order to do this, we basically have to understand all the corporates are facing limited liability, means that you can only pursue the corporation if the corporation has any debt obligation to you up to the limit of the asset. In other words, a limited liability. So therefore, default or bankruptcy is a legitimate right of a corporation. Okay, that's what we understand modern economics, right? So we have to really sort of try to come up with some model to describe the probability of default or bankruptcy. And because corporation will also disappear for reason other than default. So you have to think about the merger acquisition, for instance. That probability is essential for you to understand the probability of default, because probability of default will be essential to your lending decision and or risk management. Okay, so in order to do that, you must understand also or model the probability of other corporate exit, like merger acquisition, because a survival means a survive merger acquisition as well, more than just bankruptcy and default. So these things are naturally have to be subject to some common risk factor and have to be individual attribute. So the issue of this type has been analyzed, I don't know how long ago people started doing it, probably 100 years, because the Moody's, for instance, was doing that at the turn of a century, or previous century. I'm not talking about this century. So this has a long history, right? But the modern methodology and the data science or the more modern economic finance theory can help. So this is not pure data science, right? This has to have an economic theory and financial theory behind it. That's what we do. So the point is to understand there will be a lot of common driver, a lot of individual attributes, which will determine this kind of probability. So all these attributes are expected to be dependent over time and also cross-sectionally correlated, because we live in a semi-economy. Economy goes through business cycle, and the firms in the economy will do well together, do well, or do poorly together, right? So these are very dynamic, very correlated structure. And so that is complication, right? So dimension is high. So give me an example. If you actually talk about 10,000 corporate, if you try to model this somehow, use a 5 individual attribute plus 3 common driver. Common means that it applies to all 10,000 corporates, right? And if you individual means that individual has a different number, a different kind of variables. So together will be over 50,000 dimensional. And 50,000 dimensional time series is no joke, right? But I'm actually understating, because I'm actually talking about 70,000 dimensional exchange traded corporate. If we consider SME, that will be the astronomical number, right? If you don't consider that. Okay, but anyway, you have to realize the kind of data in order to model is something I call the incomplete data panel. It's a panel of for corporation, for various attributes, but you have to realize some company disappear, like Lehman Brothers is no longer with us, right? It bankrupt, it's gone. And we have IPOs, like for instance, M Financial is going to be IPO, right? So you have something coming on board, some company leaving. So it's a data panel of time panel with a lot of obligors, a corporation in this case. Each of the corporation at a particular time point, you have an array of information about it. Okay, that's the kind of data we are dealing with. Anyway, if you think about probability of default as a model, it basically is a function, right? It's some sort of nonlinear function. It's a function of attributes. That attribute means individual attribute as well as common drivers at the economy at that time point. So it'll be I and the T to indicate it, and the X itself is a vector, right? So what we want to know if Y equal to 1, Y is the outcome, is a default. Then we must have some sort of probability assessment of that, right? If a 2 is other corporate exit, it has to be 2. So it's a categorical outcome, but we want to assess the probability of that. But on top of that, we also have to consider, at a given point in time, we're not only interested in default over 3 months, we may be interested in over 5 years or 2 years. And so there are different horizons of interest. Users are concerned about different horizons. If I lend money to you over 3 months, I wouldn't care less beyond 3 months, right? So every user is facing different kind of horizon of interest. But you have to remember, this system must be monotonic in horizon, because default probability over 6 months, it had to be greater than 3 months, right? You can say that's must have condition. If it's not, it means that this thing is overfitted, right? And it's natural in that way. So there's a lot of constraints. So I'm not going to burden you with those, and I will take months to talk about. But what I'm saying is we're going to have a system. We have a huge amount of data. They are time series dependent, cross-sectionally correlated, and there's a lot of constraint on the functional form. Okay, that requires theoretical understanding, but it will also face a gigantic estimation and implementation task. Okay, so specifically, the task I'm facing is about 70,000 exchange-listed firms in 133 economies. That's what the Credit Research Initiative have been doing. It's the world's largest corporate default prediction system, maintained at created at the National University of Singapore, previously at the Risk Management Institute, and this one going to be moved to Asian Institute of Digital Finance soon. So anyway, among 70,000, say Lehman Brothers is gone already. So there are about over 36,000 are currently active, which are your very interest because they're a live company for business usage application of your concern. But don't forget, those old companies are very important for modeling, right? So you need to have those. And we operate with 3 time zones. So we're not just a research platform. We're researching at the same time we're a production platform. We do daily updates of the entire system because information do come in on a real-time basis, right? But we update on 3 time zone basis to be practical, but it also had to be catered to the reality. So we operate the Singapore time zone, New York time zone, and the London time zone in that sense. So our computing tasks involve periodic model calibration, means re-estimation of a huge system, and the default updating, reflecting value change. For instance, stock price has moved. Okay, the new financial statement come out and those kind of stuff. And interest rate has changed, the various aggregation into the sector, into the economy. That's what we do, in a nutshell. So our computing tasks are numerous as a lot. So I'm going to group into 4 categories. So daily tasks, monthly tasks, and quarterly and yearly. Okay. So now we start as a background. You understand my experiments on the NSCC. Okay. So we have daily tasks. So I'm going to talk about daily tasks, immediately go into the experiment. Then come back if we have time to talk about other tasks. So to give you a holistic understanding. Okay. Our daily task is we had to calculate every firm's PD Okay, when I say PD, it's not probability default only, it's a turn structural PD, means that for 1 month, for 3 months, for 6 months, for 1 year, and so on and so forth. It's a whole shebang of a probability of default. In order to do that, we also have to calculate probability of other exits in order to deduce longer term PD. And there's something called actuarial spread. I'm not going to burden you with that. So every day we have to calculate this. This calculation is not model estimation, it's a calculation because we have model parameter in place, we have functional form, we just have to calculate. And this calculation runs very fast, okay? But there's one thing daily task is very time consuming, it's a portfolio default rate distribution. Because when we aggregate, say for Singapore or for the United States, for China, you can think about, say China has a 4,000 some exchange traded company today, okay, on the main board. And they are all correlated in some sense. In order to do that default rate distribution, what I meant by default rate distribution is basically what's the probability of no default over, say, 3 months for China, a probability of 1 default over 3 months for China, you know, that kind of calculation. And it's very involved, right? Even without model estimation, it's very involved. It's very time consuming. So every day we'll spend about 3.5 hours just to do this. In a 3.5 on single computer, no. It turns out we have a 20-some computer, and we take out about 20-some very sort of good computer, desktop computer, sort of higher end desktop computer. Typical is a 12 CPU cores. Now they all have users. So owners are continue to use their computer, but we'll take out in the 12 core case, take out 8 cores from that computer. We use some load balancer and to assign them. So they are basically our private cloud for computing. And we run the software, we use we code everything in Julia 1.0, 1.0.3. That's the current version we are using. So the whole daily calculation will take 3.5 hours on this 20-some plus computer, okay? And, you know, so you can see this part is not research because it's what we have to do. We have to stick to a schedule because they're time zone. Okay, we take about 3.5 hours of pure computing just on this. You know, among the computation, there are lots of tedious calculation here and there. They're not necessarily time consuming, but there are many tasks. But it's one part of the task is related to portfolio default rate distribution that is exceedingly time consuming. That is part take 2.5 hours to 3 hours. Okay, so computing time, because we have to calculate for over 3,000 some firm. Earlier I mentioned 70,000 firm. Remember, many of those are already defaulted of already undergone the merger acquisition no longer in existence. For the daily calculation, we only had to calculate for the active firm. That's over 36,000 firms, okay? So what we do is we group them, we divide into 100 firm slices. In each one of these tasks, it's completely parallel, right? Because it's a dumb calculation, the parallel calculation, it's dumb parallel. So you can see that the more computer will do better, right, naturally. So that leads me to think about NSCCs, right? Because it's obvious they have a lot more cores, right? I could just do this calculation much faster instead of have to do many rounds of this. Okay, so let me skip and we'll just go all the way to the end to tell you the experimental one. And I have time, I go back to the earlier discussion to complete the rest of them. So experimental one, we on this, is we take out the 21 tasks, about 300 plus tests, because earlier I talked about it, right? We have about over 36,000 firms. We put into 100 groups, and so we have a 300 some daily tasks. So we didn't run the whole thing, we run the 21 task out of these 300 because we think that's enough to do assessment. And this is the part we take 2.5 hours to 3 hours, right, to complete for us the 300 some plus task. And each one of these completely parallel, dumb parallel, right? So we run on the NSCC's nodes, and each of the nodes they have is 24 CPU cores, I understand. And each one of these 21 tasks actually took about 4 to 6 minutes to complete. Okay, and of course, I'm not counting queuing time. Okay, but I think if you just run on typical account, probably don't get this kind of queuing time. You get an even worse queuing time. Because what we have done is we actually with their NSCC's assistant, they assign a technician to assist us to do this experiment. But we still face queuing time. The queuing time is ranging from 10 to 30 minutes. Okay, so now taking our queuing time is 4 to 6 minutes. So in comparison to what we do internally, we do it our computer slightly slower than their nodes, and because we have between 8 to 12 cores, and we also assign take only partially out because users are still using it. So, but anyway, if we run it, it will about take a 7 to 10 minutes on individual tasks. But we don't face a queuing time, right? Okay, so what happened is if we have a reasonable queuing time and NSCC, and that would be very realistic alternative for us. So in other words, we think if we are given the queuing time, it's supposed the queuing time will not go to say 10 minutes, okay? And then we probably can get our daily task done in 15 minutes, as opposed we are 2.5 hours to 3 hours. So I'm looking at the NSCC as a real possibilities. I'm hoping once with a new system, they somehow can commit to some sort of queuing time, minimum queuing time. The reason I mention this, I think many users probably will appreciate, will think the issue in my kind of mindset. The reason is the computational consideration I'm having is not research, it's a production, okay? This is really a production need because we have a time zone, we have a production schedule must be met. Some amount of queuing time is fine. Suppose the queuing time cannot be controlled, and we're gonna have a difficulty because we're gonna fail to meet the production schedule. So that, but anyway, I remain optimistic. I think NSCC does present the alternative for our computation, not just for this daily task, because this daily task is done parallel. It doesn't really need supercomputing system. You just need many computers because we can try to build a private cloud. And for instance, I'm thinking as alternative, I can try to talk to other institute and try to sort of get someone's help to make their idle computer or semi-idle computer to assist our calculation. That's another alternative, right? So there are ways to go about computational need in garden variety way. But NSCC definitely is one possibility. I still have a few minutes, right? I think, right? Is that correct, Vanessa?
Yeah, Proton. Yeah, I think you can just have 1 or 2 minutes more to, yeah.
Okay, so let me sort of take you through then the other task we have, so you can understand what I'm saying. So far, daily task has nothing to do with a model calibration or estimation. It's just computing, right? Computing with a fixed model already. But every month we update the model parameters. From time to time, we'll revise model too. That will be some research outcome, development outcome. So the monthly task we'll do, it's very time consuming, okay? So we have two kind of runs. We divide the model to 6 regions. Globally, we divide to 6 regions, right? So every month we had to estimate the point, we had to produce a point estimate of the PD model. There are 6 models for 6 regions. Each of the model has over 50 parameters, okay? And for those who get into the high dimensional optimization, they realize high parameters, it is sometimes convergence can even be an issue. But here we actually use a sequential Monte Carlo technique, okay? It's very stable technique. I've been doing a lot of research on that. So we actually invent optimization technique on this kind of model as well. So we have to estimate very extensive system, okay? Because of sequential Monte Carlo, so every month we update the model for point estimate, but that will take 2 to 4 hours for each of the model. But then, in order to do statistics, because some users want to know the statistic, want to know the confidence interval or parameter, now we have to do a full sequential Monte Carlo run. That's very different. For those who are interested, we can talk about that. But that is because we use a self-normalizing statistics and to go back to the full run. So whenever we have to update the confidence interval, that it takes 2 to 3 days to run for each model. Okay, this place I also think there is a possibility of using NSCC system to help us. Okay, but we haven't experimented on this yet. And so this is a place we use different kind of computing facility. We basically have one K80 and two P100 GPU, because this model calibration use a lot of GPU. And you take about 10 gigabytes memory and 5 gigabytes of GPU, and data goes in there, and we just do a lot of calculation, okay? And it takes 2-3 days for each one of the models. So you can imagine, I would like to free myself if I have a better computing facility for this. Now, we also have a quarterly test. That's a distant default calibration. For those who know about finance, that's basically a sort of theoretical model outcome. And if you want a sort of a layman way of understanding, basically it's a leverage ratio adjusted by asset volatility, standardization. That is all based on model. So basically we use a model to calculate input into another model. Okay, that's basically it. This input model itself, we also do a quarterly update. So parameter recalibration. How long will it do that? And you think about it, our data is about 30 years in history. So why do we have to recalculate all parameters, you may wonder. So suppose 208, why do I have to recompute? The reality of life is this: data get revised because the reported data do have mistakes. You know, like Enron, for instance, for those who understand that one, the financial statement was doctored, and later it was revision and revision and revision. Okay, so some old data do get revised, some due to database error, some due to some due to accounting fraud, some due to some sort of genuine mistake somehow. So data do get revised. So we just
Prof, Duan, if you can just wrap up.
Okay,
yeah,
so I'm wrapping up. The basic is saying that suppose you have to reestimate, and that's a lot of reestimation. So we take 1 or 2 days each month for each month of the calculation, but we have 30 years. You can sort of imagine that. So that will reserve it to quarterly. Then we also have an annual, yearly calculation. I'm going to skip that. Okay, so thank you very much. I will be happy to answer questions you might have later.
Thank you, Prof. Duan.
Okay.
Next up, we have Dr. Stefan, Deputy Director at AI Singapore. Dr. Stefan, you may share your screen.
Yes, hi, good morning, everyone. Let me just try to share my slides here. Okay, are we good?
Yep.
All right, yes, hi, thanks for joining, and thanks to our NSCC hosts for inviting me to this seminar. My name is Stefan Winkler. I'm with AI Singapore. And so what I like to do today in the 20 minutes that I have is two things. I'd like to share a little bit about the various programs that we run at AI Singapore, because I think some of them may be of interest to you. And then I'd also like to share some of the more concrete use cases where we've actually worked with NSCC and used the NSCC compute facilities for certain of our projects. So before we get into that, just a bit of background on AI Singapore. AI Singapore was created in 2017 with intent to set up an entity to really support the AI ecosystem here in Singapore. We're funded by the National Research Foundation and the Smart Nation Digital Government Office. And we work with all the universities here in Singapore, as well as A-Star. We have a variety of missions, which I'll share with you on the next slide. These are shown here. One is to support fundamental AI research. Another is to address challenges, more targeted research and problem statements. Then we have AI innovation, essentially working with industry and also providing training and resources for to build up the talent pipeline here in Singapore. The fourth one is a relatively new activity. This is called AI Makerspace, which is a platform for AI tools, data sets, training, and other resources. And I'll go into each of those for a few minutes. So let's start with the research pillar. Here the mission is really to make sure that Singapore stays at the forefront of AI research leadership. In fact, Singapore is doing very, very well for such a small country in terms of the research capabilities, the researchers that we have here in Singapore. And we want to make sure that they have the support they need. And so we have various schemes to do so. And these schemes are really designed to support university faculty that's working in the AI domain to come up with new tools, new techniques, and so on. We also have a PhD fellowship program that we launched recently. That's very attractive, trying to attract students to pursue PhDs at the local universities. And we also have programs to set up and encourage collaborations between researchers and institutions. Now, in terms of research, there are a few domains that we are focusing on and that we'd like to support and encourage. And those are shown here on this slide. So we are interested in trustworthy and explainable AI, privacy-aware AI, resource-efficient AI, collaborative AI, and also AI that keeps on learning. The reason we've picked these 5 topics is that these are, of course, cutting-edge research areas in this space, and so this is already something that a lot of researchers are working on. And B, that these areas are also very meaningful and very important locally, right? So let me use the example of the resource-efficient AI, for example. Singapore is a relatively small country, so the data sets that we can gather are necessarily limited, right? We don't have the size of US or China in terms of people or companies or data for many domains. But the data sets that we have are high quality. So it makes sense to focus on learning from these particular data sets, right? That are very small, but of high quality. How can these be used to still train interesting models and high performant models? So this is one example, and the same is true for the other topics as well. Now, in the technology pillar, we focus on national challenges. So as I said, it's a more targeted research approach. It's still a research funding program, but we have clear goals and clear measurements when we design these programs. I'll talk a bit more about the Grand Challenge program, which you may have heard about, but we're also in the process of preparing other smaller scale challenges. And recently, for example, we did an ideation challenge on AI for COVID-19. So grand challenges, they are, of course, big in scope. Important issues and problems that are faced here and globally that we think AI can address. And we want these challenges to be inspiring, not only to our stakeholders or the researchers, but also the general public. We want these challenges to have an impact, and we want these challenges to be measurable, right? So we want to quantify the progress that the teams and the projects make in their work. And healthcare is the first domain that we picked for these grand challenges, and I'll share more on the next slide. And we're currently trying to decide what will be the next domain that we can have a grand challenge in. The AI in Health Grand Challenge actually started a couple of years ago, and the problem statement that we designed was, how can AI help primary care teams stop or slow disease progression and complication development in 3H patients by 20% in 5 years? And these 3H are the top 3 chronic diseases, including high cholesterol, high blood pressure, diabetes that people and patients face. And this is also aligned with the National AI Strategy, which has a focus on chronic disease management. So as I said, it's a large program. It goes over 5 years. It started last year, so we still have until 2024 with overall budget of about $35 million. And we expect a similar configuration for future challenges. So we currently have 3 multidisciplinary teams working on this challenge. They consist of AI researchers teaming up with clinicians, social scientists, and other experts to work on this challenge. And we're also looking, because of the scale of the data sets, once we get to a national level and also roll out on a national scale, to really tap on NSCC resources to enable building models and processing data on such a scale. On AI innovation, this is where we work very closely with industry, with companies, but also with government agencies. So we have a program called 100 Experiments that I'll share a bit more about. And we have various training programs that I'll come back to at the end. So all these acronyms at the bottom, AI for I and so on, these are our different training programs that I'll talk a little bit about towards the end if there's still time. Now, 100 Experiments is a very popular program. The way it works is that company comes to us with a business problem that they think can be solved through AI. And the other thing we like them to have is the data for solving this problem, right? With AI, you always need to have data, or at least it makes the start much easier. On AI Singapore side, we team them up with the research expertise and also the engineering team that's supported by us, up to about 250K. And the company then also comes in with matching in-kind and cash contributions. Now, the goal of these projects is to really develop a minimum viable model within a period of 9 to 18 months. That depends a bit on the project complexity and the scope. And as part of this, we also do the training of our apprentices, which I'll come back to at the end. So it's a very nice sort of synergy between solving problems that businesses have, for which they may not have the AI expertise to solve them on their own, and also at the same time building up the AI expertise and engineering resources that then allows these businesses to continue and build up their own teams potentially in the future. Now, let me share a few examples for these 100E projects. So here I'll talk about some of the use cases in a bit more detail. And here they really cover all different kinds of domains, from engineering, like lift maintenance, or equipment failures, anomaly detection in equipment, to the financial domain, for example, credit scoring for credit applications, to transportation, where we do driver scoring, behavior analysis, and the medical domain, such as chronic wound management, or a more core AI functionality, such as natural language processing. So let me, we've now, I think, 30 or 40 or even more 100E projects that are either concluded or currently ongoing. So it's really a wide variety. Now, I'll go a little bit deeper into those projects where we had the need for larger computing power and where we collaborated with NSCC. So the first one is a project that was done together with Chronicare, a local startup that looks at wound assessment and wound management. So wound management, or for the assessment in particular, this is done by nurses, and it's usually a quite time-consuming process. It can take up to half an hour. Very few nurses have the training required to do this well, so the results vary a lot, between nurses and also between hospitals. So the idea for this project was to develop an automatic assessment tool that can do this objectively using a scanner, camera-based information that is used to scan the wound and then analyzes it automatically and comes up with assessment and recommendations for the nurses and the clinicians and the caregivers. And through the system, we were able to reduce the time used for this assessment quite drastically, and of course in the process also save money for the hospitals. It is now deployed in a few hospitals around here. And for training these models, the data sets were large enough that we actually had the need to use NSCC resources to do some of the model training in certain stages of the project, and that really saved a lot of time. For the next example, I'll also share some of this compute approaches, and that's the speech lab. A speech lab is interesting because we created it when we had multiple requests for essentially speech recognition for local local speech, right? So locally, you hear a lot of Singlish, a lot of code switching. In the same sentence, people might mix English, Mandarin, and Malay words. And so the tools that are available from Google or Microsoft for speech recognition are not able to handle that. So there was a need to develop this ourselves. And we had a few agencies and companies who were actually interested in that. So we got the help of these very renowned professors from NUS and NTU. They're really experts in that space, and they work with us to implement this code switch speech recognition capable system. And that's now available. Can even be tested out as a trial on our website. And we have then also customized the speech engine for different domains. You can see some examples at the bottom here. So of course, for call centers, this is very interesting to just record and transcribe conversations with customers, with callers. And then if you sort of customize this for specific domains, such as interviews or medical consultations, you can make it even more accurate and also customize the interface for these different use cases. And that's what we've done. And for this particular problem, the data sets that the teams work with were really large. So they had more than 10,000 hours of speech data, which were then augmented through various processes to generate even larger data sets. So you can imagine it's already difficult to store and even more difficult to analyze and train with. And the teams found that during certain steps of the process, such as the feature generation on their local machines, the cluster would crash or not work properly just because of the heavy I/O that was involved in doing so. And then because of the large data set size that the team worked with, they ran into a bottleneck for their GPUs. The GPU cluster did not have enough memory, wasn't powerful enough. So everything was very slow and troublesome, with crashes in between. And so the team decided to use the NSCC resources for actually implementing some of the training for different stages of their models for automatic speech recognition. And they did a side-by-side comparison of the training that they did on their local machines previously, and then once they had migrated all of this to NSCC, and it really bought them a lot of time and a lot of speed up and also a lot of reliability in the process. So that was a pretty successful implementation that they managed to do there. Now, as I said, we've done quite a few projects over the past couple of years with different companies ranging from local startups all the way to large multinational corporations, and also some of the government agencies here in Singapore. Now, the last pillar that I want to talk about is this AI Makerspace. It's a relatively new thing. You can go there, have a look. It's really a platform that provides a suite of tools, pre-built solutions, open data sets, resources for training, and you can also tap into engineering services that we offer. So this is, the idea for this is to offer a place for SMEs, startups that need to build something using AI tools quickly and may not know where to start. So here we provide some of the tools to get you started on that AI journey. So if you go to the Makerspace, makerspace.aisingapore.org, you can just create an account, log in. We have a place for learning with different learning and training material that we've developed over the years. We have a space where we capture all the tools and software resources, and of course, also sharing, so a forum and so on. And this is, in fact, something that we, just a few weeks ago, we announced this, that we have an AI Makerspace now at Singapore Polytechnic that essentially makes use of these resources to, tell their students how to build AI tools, use it for their education, for their courses, and also use it for working with their industrial partners to develop AI solutions. So that's quite an interesting approach, and we're certainly open to working with other partners on this as well. Here's an overview of some of the tools that are already available. So remember, we just launched this, so there's just a handful, but we plan to add a few new ones every month as we go on. So we already have tools for robotic process automation, sort of automating repetitive interface tasks, manual tasks. We have some of the tools from the speech lab for natural language processing, speech to text transcription. We have some computer vision tools for object detection, object identification, segmentation, and we even have tools for logistics and scheduling. Now, lastly, if I still have, let me just check the time. Okay, still have a couple of minutes to go through the talent programs, which you may have seen on our website as well. So the apprenticeship program is the one that I already mentioned in connection with our 100E. It's tightly connected. The apprentices essentially come on board as full-time apprentices to go through the program, and then they get the very hands-on practical experience in working with the companies on these particular problems to develop those models for the 100E projects. So it's a very nice program that really produces people who have these hands-on skills to use and develop AI tools. We have less time-intensive programs. For example, AI for industry. It's a program designed for professionals who want to also get their hands dirty in trying out some machine learning models, start to use some data sets. So it's a part-time program that can be done over a period of 12 months. And is a very good introduction if you actually want to do some hands-on work in AI. And the most general program, the easiest program is AI for everyone. It's just a 3-hour workshop. We conduct it now virtually. So this is for people who know very little or nothing about AI and just want to learn what is it about, what does AI do, what does it not do, and so on. So really the first introduction to AI. And then we also have a couple of programs for students that we roll out in connection or in collaboration with schools for students of different levels. All right. I think that brings me to the end of my talk. On our website, you can find a lot more information about all of the programs that I mentioned, but feel free also to reach out to me if you have any questions, and I'll be around for the Q&A part of the session later on. Thanks very much.
Thank you, Dr. Stefan. Next up, we have Dr. Prasanta, research scientist from IHPC A-Star. Dr. Prasanta, you can share your screen.
Yeah, thank you, Vanessa.
Yep.
Good morning, everyone. And once again, it's a pleasure being here to share some insights about network science applications in finance and education. So I think similar to some of the previous speakers, I'd like to kind of split my talk into 2 parts. For the first part, I'd like to focus on introducing network science as a field that's kind of ripe for high performance computing applications. And hopefully some of you might find this relatable in terms of the area of work that you are interested in. For the second part of my talk, I'll look at, or I'll rather introduce certain use cases with real world problems and data sets that I've been working on. And hopefully, especially if you're working on social science and finance related problems, they should be of some interest to you. All right, so let's start with a fun example of why I feel networks or graphs in general can help us understand phenomena in a new light. So this was actually from a published paper back in 2011 that looks at how ingredients share flavor compounds. So the network that you see on screen is actually a network of food ingredients. So each node in this network is a food ingredient, and if 2 ingredients share or co-occur in a recipe, they have a link or tie between them. So this network was actually constructed from an analysis of over 50,000 recipes. So there's a little bit of big data about food recipes involved, right? So one of the things that you can immediately observe just by looking at this network is that while there are some ingredients that are particular to certain cultures or geographic communities, there are other ingredients that kind of serve as crossover ingredients across cultures, right? So garlic and tomato are a good example that find pride of mention in many different recipes. While something like butter or vanilla might be more popular among the North American or West European cuisines, but not so much in, say, East Asian. So the reason I'm sort of wanted to start with this is to kind of reinforce the point that this is not an area where traditionally we've used networks or graphs, but by looking at this existing sector through the lens of network science, we can quickly generate insights that might be useful for various purposes. So let's take another example, and this is probably closer to what we are experiencing today. So there's actually been studies looking at how social networks can play a very important role during public health crisis. And again, this should be very obvious to all of us now, that we do things like contact tracing, for instance, which use the idea of social networks to understand the spread or contagion of a particular disease. So this particular network that you see on the screen is from, again, a published research. And this was from back in 2009, where there was a particularly bad outbreak of the H1N1 flu in the US. And what researchers found was that if you were able to sample a network properly, so if you're able to follow a certain network, you would be able to predict the onset of some of these, or onset and spread of some of these diseases ahead of the broader population. All right, so in this particular case, this is a network of college students from Harvard, and researchers were able to show that first, students with a higher centrality, which means students that were better connected within the student community, were more likely to get infected. And then their contacts or friends were quicker to get infected than a randomly picked person in the broader population. So the idea of pointing this out is to kind of argue that networks, large complex networks, can serve a critical role in sensing during public health crises like COVID-19, for instance. So before I get into some of the more high performance computing applications, probably helpful to just give like a network 101 slide in case a lot of you might not be familiar with graphs and networks. So very simply put, a network is a collection of nodes and links, right? So the individual nodes can represent humans, organizations, entities, states, etc. Two nodes can be connected by links or edges, and these represent various kinds of relationships. So the relationships could be, friendship or some, kinship or other kinds of relationship in case of a social network, or it could even mean, collaboration, co-authorship, or even some similarity of some kind. But what's the purpose? Like, what's the application of representing, a phenomena using a social network? Well, if you take the example on the screen, if you have a social network with a couple of individuals, we should be able to use that network to solve predictive problems. So for example, given this social network, can we predict who Alice will befriend next in the network? So what's the next link that's going to form in this network? Alternatively, we should be able to explain why or how did Alice befriend Bob or Charlie, right? So we can answer various kinds of questions once we have a network representation. Now, all right, this is probably the part where I want to emphasize the most in this particular talk. A key attribute or characteristic of networks is that the size of the network, the scale of the networks can vary substantially depending on what you're working on or what kind of a researcher you are. So for instance, I work on social networks a lot. So for me, if I'm using like a family network, which can have maybe 20 to 30 individuals, so that's an example of a small network. I work on digital networks a lot. So generally or typically, the network data sets that I work with have from in the order of maybe several hundred thousands to 1 million nodes. The Facebook graph, for instance, has over 2 billion nodes at this point. So I think the last I checked, they had close to 2.7 billion active users. But just to kind of elaborate on, or rather extrapolate from this point, you could even scale higher up depending on your area of work. So if you talk to a neuroscientist, they would probably give you an example like this, which is, so the one example that you see on the screen is from a fully mapped brain of a mouse. And this is one of the largest ever brains that have been fully mapped. And this is only a very, very tiny subset of the brain. So this is like a 450 cross 450 cross 150 micrometer part of the brain. And this already has over 1,200 connected neurons, right? So even mapping out this brain structure for a tiny slice of a brain is a high performance computing application. And this actually required a customized electron microscope plus very advanced 3D imaging equipment to even generate this plot that you're seeing on the screen. And finally, I mean, if you're interested in astronomy or generally stargazing, I mean, recently we found out that the Milky Way, the galaxy that's home to all of us, is actually part of a much larger supercluster. As for those of you who don't know, a supercluster is essentially a network of galaxies. So this particular supercluster, Liniacia, is home to our Milky Way galaxy, and this actually has close to 100,000 galaxies, all right, that are connected to each other. And there are several hundreds of thousands of superclusters in the universe. The exact number is still not, we still don't have a good estimate of how many superclusters there are in the universe. But we know that superclusters are the largest networks that we can think about in the universe. And the supercluster itself is a network of many hundreds and thousands of galaxies. So if you're an astronomer, then this is the scale of the network that you are dealing with. So again, you can imagine that from small familial networks to intergalactic networks, depending on your field of research, your high performance computing needs for studying networks can vary substantially. So one of the other interesting points to highlight here is it's not just the size of the network. Even for smaller, moderately sized networks, the number of relationships that you might have to model can scale rather quickly. So to give an example of a very popular networks anecdote or problem that scientists have been working on, some of you might have heard of the 6 degrees of separation that a lot of us find very interesting. So the idea of 6 degrees of separation is that if you take any 2 random individuals in the world, the studies have shown that you can reach or you can create a path from the first individual to the second individual in no more than 6 hops. Right, so it means that you can know any other randomly picked person in this world through no more than 6 individuals, or rather 6 hops. Now, researchers at Facebook tried to replicate that experiment on the Facebook friendship network, and they found that the degree of separation on Facebook is actually substantially lower than in the real world. And the mean distance between any 2 Facebook users is around 3.5, which means you can take any Facebook user and create like a walk or a path to any other Facebook user. And that path on an average would be less than 4 hops. And Facebook obviously uses this to talk about how digital platforms are making the world a shorter place, etc. But anyway, without getting into what that signifies, I want to draw your attention to how to compute that distance, right? And one of my contention is that computing this distance at scale is both a high performance computing problem as well as a statistical challenge. And just to give you, a very quick kind of taste of why this is a high performance computing problem. So let's assume that your Facebook network, in your network, you have 100 friends, 100. So if you have 100 users and in the Facebook and each user has 100 friends, then you can imagine that you already have 10 square friends, right? So 100 into 100 friends at a distance of 2. And so if you increase that distance to 3, it would be 100 into 100 into 100 friends at that distance, right? So obviously you can imagine that this scales really, really quickly. Now add to that the fact that you have over 2 billion active users. So which means that if you have to compute that shortest path distance, you would have to run that calculation for 2 billion users, pairs of 2 billion users, right? So obviously this creates a huge computational burden, even with approximations in place. So the way the researchers at Facebook solve it is by using a mathematical approximation algorithm. But even with that approximation algorithm, it's still a very sizable computational burden. Here's another example of why network features can be computationally very expensive to compute. So a very popular centrality measure that we frequently use in social networks is called betweenness centrality. So what betweenness captures as a measure is how many shortest paths in the network include that particular node. So in this figure that you see on the screen, the node number 4 has particularly high betweenness because most of the shortest paths in the network include this particular node. So you can imagine that a node with high betweenness is a node that has very high brokerage potential, right? So it controls flow of resources from one part of the network to another. So that's why understanding nodes, or rather uncovering nodes with high betweenness is a very critical problem in many network science applications. So this actually, you can imagine, right? This requires computation of shortest paths, all possible shortest paths in the network, which is again, a very computationally intensive problem. So there has been advances in this field where researchers have used GPU implementations of betweenness centrality, which has led to significant speed up. So for example, the paper I think that is cited on the screen uses a GPU version of a betweenness centrality measure. And that I think leads to significant speed ups of that can help generate this measure rather quickly. All right, so given that backdrop, let me just try to talk about some specific problems and studies that I've been interested in. The first example I'm going to talk about comes from finance. And I think you'll see some overlap with some of the things Prof. Duan was mentioning early on. So while Prof. Duan was talking about corporate defaults, one of the problems that I'm very interested in is the idea of personal loan defaults, especially in emerging markets. And the reason I work with emerging markets a lot is because a lot of countries in this part of the world lack established credit infrastructure. So there is fewer financial data points using which you can base credit decisions. So one of the things that we've seen in these markets is the rise of big data driven credit scoring, data that comes from objective data that comes from things like your mobile phones, for instance. There's been a lot of ongoing work in this field. And this has its own challenges, right? So even without getting into that, I wanted to highlight that one of the problems that we face in this sector is the availability of very good predictive data sources. And this is an area where I've been trying to use social networks a lot, because in many of these communities, using social network features tend to offer novel information signals that can help predict loan defaults a lot better. So the idea that your network might hold important information about you as a borrower is actually a pretty novel insight that can drive these kind of applications. But again, finding these network predictors, as you've seen in the past couple of slides, can be a high performance computing problem, depending on what feature you're using. The second part of this problem is arguably more interesting, which is once you see a couple of defaults, can you then predict if that default is going to spread through the borrower network, right? So if you have, say, a group of borrowers and you see that certain individuals have defaulted, can you then predict what's the likelihood that their connections or their friends are also going to default in the next month or next year, right? So this is a problem of contagion in loan defaults. And once again, the kind of estimation and simulation models that we use to make some of these inferences can be computationally very expensive, making this an area that's ripe for high performance computing. So this is actually just to show you some real data from a project that we've been working on with a micro lending company from an Asian city. And so the two networks that you see on the screen are for a low credit risk and high credit risk sample, okay? The nodes in red are nodes that have paid back, and the nodes in blue are the nodes that have defaulted on their loans. And so based on our statistical modeling, we've actually been able to show that depending on the level of credit risk, the susceptibility of nodes or borrowers to influence from their peers can follow very different distributions. So while in low credit risk samples, we see that most of the borrowers are kind of clustered around the 0 mark. So there's very little influence from peers. However, from the high credit risk sample, we can observe that there's kind of a bimodal distribution where some borrowers tend to show positive influence, which means they kind of are, they follow the direction of their peers, while other borrowers show negative influence, which means they are also influenced by their peers, but opposite in direction. So if a lot of their peers default, they tend to pay back their loans on time and vice versa. So it's a very interesting insight that we can derive by analyzing networks and what happens to borrower and default behavior, especially when you're embedded in a social network, right? So this is ongoing work, and we're trying to scale up this estimation for larger samples, and this is where high-performance computing is very useful. Right, so this is the last part of my presentation, where I'm going to talk about an example from education. And I think some of you mentioned in the chat window already that you're interested in this particular context. This should be of some value to you. So one of the things that I'm particularly very interested to understand is how online student networks operate and how network interactions lead to tangible changes in academic performance for the students and subsequently in their job outcomes, all right? This is, again, a very classic area of research in education, understanding how social networks affect educational outcomes. However, for the first time, perhaps, we now have a lot of fine-grained data using which we can study these interactions and kind of test some of these hypotheses in the real world. And again, solving this problem with large interaction data sets require both experimental innovations as well as innovations that use high-performance simulations and models. Another reason why this has become very timely now during COVID-19 is because we have been moving a lot of our educational infrastructure online. So a lot of teaching is happening online, a lot of projects and discussions are happening online. So we are now seeing the emergence of a new kind of a student network that's primarily online and then maybe secondarily offline. So maybe understanding how these online interaction networks are different from traditional social networks might hold the key to kind of uncovering how these networks are going to lead to downstream outcomes like academic performance and jobs. And maybe some of these online networks can even drive offline interactions once these COVID-19 restrictions are removed. So we don't know. So this is a really golden opportunity for us to kind of try and analyze some of these online networks to understand how students really are adapting to this new normal. All right. So this is from an actual study that I'm currently working on, and we have an early version of this that we presented at a conference a couple of years back. So using a large data set of online student networks and their interactions, we are trying to answer these three questions. First, we want to understand if students form networks based on homophily or similarity in academic performance. So are high-performing students only making friends with other high-performing students? Are low-achieving students forming friends with low-achieving students, and vice versa? Is there evidence of peer influence? Is there evidence in the data to suggest that students are learning and improving based on the achievements of their peers? And finally, do the strengths of this homophily and peer influence vary as a function of some student level characteristics like their academic abilities? So even without getting into the details of the modeling, just wanted to show you, like a quick visualization of how the student networks evolved over an 8-semester term, of an 8-semester program. And so one thing you'd notice is over the years, over the semesters, students were increasingly more clustered based on their academic outcomes. So especially towards the later semesters, you'd see that the high-performing students, GPAs 3 and above, were clustered a lot more with similar students, while others were kind of pushed to kind of the periphery of the network. And this is, again, kind of shows some early evidence that there is some correlation or interplay between academic performance and how students form networks within universities. Just to give you kind of a quick preview of some of the results that we are seeing from our estimation approach, we actually find that most students who are middle achievers, like the middle 50 percentile, kind of show both evidence of homophily and influence, which means that they make friends with students who are similar to them in academic outcomes, and they're also equally likely to be affected by them in terms of their own academic outcomes. Now, what's very interesting is that we find that for the top 25 percentile, they show stronger homophily, which means they are much more likely than the average student to connect to other top achievers, right? Almost like, you can think of like a rich club phenomena in this educational setting. And they're also exhibiting a much stronger influence, which means they're likely to learn and grow together as kind of this community of top achieving students. Now, conversely, for bottom achievers, and again, this is bottom achievers strictly in the sense of academic scores, we see evidence of negative homophily, or what we like to call heterophily, which means that they are less likely to form connections with similarly achieving students. But more importantly, even if they're able to form networks with other students who are maybe mid or high performers, the influence that we observe is rather weak, which means they're less likely to improve their academic outcomes by learning from their networks. And this is very interesting because this points out how social networks among students naturally or organically operate. And this calls for more interventions to help some of these bottom achieving students to get more out of their academic journey. And this, again, if you're an educational researcher, you'd imagine that this has implications for preventing adverse educational outcomes like college dropouts, inadequate learning, mental health, etc. Right? So this is again a great example of how using combinations of networks and statistical models, we are able to answer fundamental questions about social networks in education. Right? So before I end, just some key takeaways. So first of all, I hope I've been able to make my case that network science has the potential to significantly transform both existing businesses as well as societal operating models. The increasing availability of big data in domains like finance, healthcare, education, etc., has opened up several new avenues for studying such real and complex networks. And largely, while analyzing such networks is at once a high performance computing as well as a statistical challenge because of the sheer scale and complexity of these networks, I still have hope that with the right combination of high performance computing infrastructure, such as the ones that NSCC now offers, as well as the right talent and research environment, this can be a tremendous opportunity, especially for smaller countries and with rich data sets to be ahead of the curve and really understand how some of these new domains are operating. All right, so that's my presentation. So if you have any further conversation, you want to discuss some of these projects in detail, please feel free to reach out to me and we can have a conversation. Thank you very much.
Thank you, Dr. Prasanta.
Yeah.
Next up, we have Mr. Karthik from Hexagon MSc. Mr. Karthik, would you like to share your screen?
Is my screen visible, Vanessa?
Yes.
Okay, perfect. Right. So first of all, I'm really thankful to NSCC for the opportunity. And secondly, I must mention that all my prior presentations were really outstanding. I myself am a learner today, I feel. I've learned a lot from my previous presenters, and I hope that I can match to their standards of presentation. So today, I represent Hexagon, and we are continuously working with NSCC on multiple forums in the areas of scalable engineering simulations. Now, the audience today, to keep them engaged, I have really tried to put certain examples which they can relate to. I'm just switching on my PowerPoint. Yeah. So moving forward, I would like to cover certain applications in electronics and how simulation really helps the area of electronics, followed by COVID research and how has simulation along with the HPC capabilities or the scalability feature has really helped us, narrow down a lot of particle dynamics understandings. And then some examples on large area simulations, which are very critical for city planning, town planning, and those sort of localized smart city planning initiatives. And how does simulation really contribute in that area? So starting with electronic application, of course, I just wanted to take a very simple and a relatable example of a gaming console, right? So when we take a gaming console, as a user, we may not know the complexity that is involved within a gaming console. But what really happens is a host of eventuality is what is leading to the final outcome of a gaming console itself. So of course, it starts from designing, then you go to material. So now studying on materials is very critical when it comes to electronic components. Then you go to the structure. So I think we are all prone to dropping these kind of electronic equipment. So we need to know how the performance of this entity would be when you during a case of drop. Vibrations, now we may expose these kind of entities to vibrations, to fatigue, to temperature related aspects, drop and abuse, which is what I mentioned earlier, the plastic forming, that is the making of this entire exterior shell itself, development of tools. So there will be some specified tools that will be needed to basically machine out this entire console itself. So the tool development for that, the assembly of tools in the machineries, the tool path generation, CT scanning. Okay, so once the product is made, these products undergo CT scanning for quality checks, any misalignments, any missing components and so on. Dimensional quality, right? Again, to check whether it meets the dimensional standards, it meets the design standards. And then any issue found in this entire cycle again goes through a complete design change, right? We call it as optimization. Now, this is a very, very complex flow for a simple entity that is a console. Now, you can imagine the complexity that may build up for other complex, electronic components that we are using on a day-to-day basis. Now, taking through the detailed simulation, what may involve, this is in relation to our earlier slide. So we are aware that all these electronic entities come with a lot of PCBs and electronic units. Now, understanding the temperature and humidity aspects of this itself is a very complex simulation, followed by studying the motion. Now, since this is a 6 degrees of freedom motion, so all our consoles nowadays, gaming console, come with motion capturing, motion actuators. So you can understand how motion is typically adding to the structure. And then the acoustics. So acoustics is nothing but the ability to understand what will be the noise or the sound that you as a user will hear when you basically press on a certain switch or certain control unit. Now then the structural integrity, I think nowadays a lot of the components are coming as snap fit, that is you just press it and then fit it. So there is no more, there is very less usage of screws, nuts and bolts moving forward, because they create a lot of sound, they create a lot of vibrations and so on. Then comes your shock test, that is you hitting the object to the ground or the object falling to the ground. It could be any such test that is required to understand what happens to the component when it is dropped and what sort of implications it goes through when the drop eventuality happens. Then the molding aspects, that is your making, the making of the exterior shell itself using simulation methods. And then finally, the designing and machining aspects, that is you giving the right tool path for the machining activity to take place, and finally come up with the finished product. So as you notice, from the conceptualization or the design phase till the manufacturing and the machining phase, all the phases of developing and making a particular product can now be simulated before it is done in reality. So this gives the manufacturers, this gives the makers the benefit of understanding the entire event and then fine tune the event, make changes to the event to any suitable requirement, and then make the final outcome, which is the best possible outcome. Okay. So this is the complete integrated result that you can see of this particular console. So the PCB, now this is the snap fit simulation that was structurally analyzed. Then the thermal simulation of the entire component, the PCB and the electronic unit, the motion dynamics of the rotating equipments, and then the acoustics, the sound that it generates when you're using this particular equipment. So everything put together into one simulated outcome. Of course, this is not an easy process as it may be visible in the video itself. The process itself has to undergo a lot of high computational requirements. It requires a lot of simulation capability, and definitely it means that we are entirely dependent on HPC sort of a platform to do this sort of detailed simulation outcomes. Now, moving forward, I've just taken an example of another, I think this is one of our case study where we took up a 5,000 part server tower with cooling requirements. So this particular entity, this is just one server tower, but has almost about 5,000 parts. And it has more than 1 billion cells to basically capture every geometrical intricacies of this particular server. And so what has happened is, with the help of HPC and simulation, we are able to reduce the time by almost 50% as compared to earlier traditional methods followed by the customer. And then the time spent on cleaning up the geometry, the manual process of cleaning up and so on, has been reduced by almost 80%. Now, for the customer itself, this is a reduction of almost 3 days as compared to their initial 6 days of manual time. So this, you can see this literal comparison of how the customer used to take time and how they have gone down in time with the help of simulation followed by the HPC capability. Another example, this is one of our customer, Analog Way. I think most of you may be aware, Analog Way are the world's biggest visual display providers, and they are the ones who are available on Times Square as well. Now, their equipments are typically very, very complex. These are all video display equipments which have multiple parts, high thermal dissipation. You can see almost 2.2 kilowatts of temperatures are emitted from these equipments. There are more than 32 PCBs, more than 150 components. There are almost 23 fans and so on. Now, this again requires high performance computing. We could test it with 20 cores of HPC, and the simulation happened overnight. Now imagine ramping this up to, let's say, 1,000 cores. You can do this particular simulation within few minutes, right? Now, all these industries are hellbound on the time they spend on doing these kind of product development and assessment, and all the more very important for them to use HPC to speed up and expedite the simulation understanding. Now, moving to COVID research. We started by simulating particle dynamics. Okay, so basically you're talking about particles coming out of your your body, of course, in the form of spray. It can be in the form of coughing, sneezing, and so on. Now, that involves the dynamics of particle, how the particle moves in air, to which all places the particle reaches, and what is the humidity. So for a normal coughing person, how the particle moves. For a COVID infected person, how the particle moves, because the particle natures are different. the densities are different, the particle characteristics are different. Now, that is one complexity. The second is the particle size itself is very, very small. And when you're trying to simulate the particles of this size, you naturally have to consider computation facility, which is capable of, easily tracking these particles in space. So that is why we need large mesh sizes. And then, of course, there is complexity with coupling. That is, now you are doing particle motion, but you want to also include a human being in that. You would want to include a certain wind condition. You would want to do it in an enclosed environment. Now, we start to add complexity to the analysis, and that definitely adds a lot of computational requirement, right? So I'll take you through a few examples where we performed a lot of infection mitigation simulation just to understand how the transmission really can be addressed. So the first case.
Can you try to wrap up soon?
Yeah, sure.
Thank you.
So the first case is that of droplet spread when you perform an airway manipulation. This was a research done in Singapore for COVID-19. Then the distancing effectiveness itself with the help of droplet dynamics. So we performed certain standard distancing simulations, and then the distancing within a metro sort of an environment for a person who is wearing a mask and for a person who is not wearing a mask. How does the particle really transmit within this environment? Then in containment wards and ICUs, there are certain standard rules, which ASHRAE has given out on how the airflow can be monitored and changed in these kind of containment regions, so that you don't have too much of air recirculation happening within these sort of enclosures. And finally, the large area disinfection. I think this is what is happening in many developed and developing countries, where they're using aerial methods to do disinfection simulation. So that is another area where we performed a lot of simulation activities. I'm just taking an example of a mask which is being emulated in the simulation form, and then we are trapping the sneezing droplets within the mask region and trying to identify what are the sizes of particles that gets filtered through the mask and what are the sizes of particles that get retained within the mask. Now, this itself, we took around 144 cores of simulation capability of HPC, and a lot of particles was included with humidity consideration to do a simulation of something as small as 2 seconds. Okay. Now, with this HPC, we took almost around 6 hours to do just a 2-second simulation. Now, you can understand that if I get an opportunity to use higher HPC, you can perform a wider aspect of simulation within lesser time frame. We did a scalability study as well on 2 aspects. That is, with increase in parallelism, what really happens to the speed up when it comes to particle dynamics, and with increase in particle count, what really happens to the time that is required to simulate. So you can see both are pretty much linear. That is, with increase in particle, the problem becomes more complex, and so you need more time to simulate these kind of activities. And then with increase in HPC, or the number of cores, you can see the speed up happening, and you may be getting faster solutions as you go ahead. A similar example was performed for clean room with our HPC cloud capability with multiple scenarios. That is, with extreme industrial scenarios where we are considering nuclear, medical, and microelectronic applications within this particular clean room to understand different situations at a single time. So these are pretty much applicable for pharmaceutical and electronics industry segments, where they have many scenarios to do with different considerations and boundary conditions. And then we have extensively used cloud for this particular simulation. This is with our customer Foray. And quickly on the last part, that is large scale simulations itself. Now, when I say large scale, these are simulations which are maybe a minimum of few square meters to a few kilometers in size, and simulations involving cities and some sort of areas where there is a large scale of understanding required. So I've just taken few examples of wind flow and pollution dispersion simulations. This is required to understand the locations that are needed to position industries, position industrial sectors, housing sectors, and different city planning eventuality. And then the second is a disaster management approach, where we are simulating tsunami and then trying to understand the catastrophe that it creates, the assessment of catastrophe, disaster response, how can we effectively design a disaster response, what are the regions that the water is entering, what is the flow path of this water, how quickly the water will reach different parts of the city, and what is the infrastructure damage after the entire tsunami, basically. Now, these are all very, very high volume simulations, definitely cannot be performed without the help of high performance computing. Yeah, so we just performed a scalability study for those examples. You can see we have taken it up to 500 cores of HPC. We definitely notice a very good speed up ramping that is happening with increase in cores. We did do this with 1000 cores as well, and then we notice very good usability of HPC for these kind of large scale simulations. So with this, I end my presentation today. Please feel free to ask me any question during the question and answer sessions. Thank you so much. Thank you, Vanessa.
Next up, we have Mr. Nicolas from NVIDIA. Nicolas, can you share your screen?
Yeah, 1 second, display setting. I think it's fine this way. Sorry, it went down to the wrong screen. Let's see.
Hey, hi, Nicholas. Sorry, due to time constraint, I just don't want to delay everyone's lunch. If possible, can you do it within 10 minutes, please?
Okay. That's what happens when I'm the last. Can you see the screen? Because I'm having some problem with the screen. Can you see applications of AI? Okay.
Yes.
It's a full slide screen, right? Or
yes.
center one.
Yeah, all good.
Okay. So are you seeing the presenter view or the full screen view?
Full screen view.
Okay. It shows different here. Okay, thanks. So just to quickly get into it, I'm going to talk about a variety of AI use cases, right? And hopefully some of them might be interesting and relevant to what you do, right? So I'm going to start essentially looking at marketing, retail analytics, and customer profiling, which hopefully might be interesting to for anybody working with social sciences as well. With AI now, we can utilize CCTV cameras, for example, in stores, and also outdoor, to be able to extract very valuable information, and to use AI to do so. So, for example, stores that already have many of these cameras in operation, right, can now use the same cameras to be able to, enforce, and try to prevent, losses, which would mean essentially, people stealing. And again, they can train AI model to do that. They can also, very important, being able to do real-time and also historical profiling of the demographics and the behavior of their customers throughout the store, which then can help them to better plan and forecast in the future for both or how to organize the store, and also when it comes, for example, to staffing, availability, and so on. And based also the type of demographic you come in, then you can do also, maybe promotions targeted to them, etc. And of course, there is other things such as the Amazon type of stores in which we're trying, especially now with COVID, to make it possible for people to easily buy without having any contact with any other person, and essentially have the ability to have stores, convenience type of stores, a bit everywhere. Now, this similar tech can also be used not just in physical store, brick and mortar, but also online. And so you can think about profiling of customers, of people online is very important for advertising. Being able to put the right and relevant ads in a page, but also, for example, for recommending of product on a store website itself, or even just Netflix, or any other application that requires the ability to do very accurate and quality recommendation. So all this personalized aspect in every single technology is really critical. Our attention span is getting smaller and smaller, and so a lot of companies are working hard to be able to capture our attention in different ways, and make the most of it, especially because I said it's getting smaller and smaller. So one of the example I will show you in a moment is this one in the middle, right? In which we can do very targeted advertising, even in public, displays, ads, and make them adaptive to the audience. But the key thing in all of this is the fact that we can profile our customers, and it will be very important. Well, here the example is for retail. The reason why it's incredibly important, I feel, is because it's a technique that eventually can also be used for a variety of other use cases out there, and for anybody, even from the academic side, it can be used as a way to generate data sets, of, for example, human behavior, or demographics in particular areas, just by using AI to be able to gather this data set. Something that in the past had to be done by doing surveys or by doing people, literally, logging, who was coming in and out of certain places. So the example I'm going to share is Klook. Klook is a local company. It's actually a company based in Malaysia. We actually have this is just one. We have quite a lot of this type of companies in Southeast Asia, based in every single country in Southeast Asia, that are essentially companies where their key core product is utilizes AI, right? And without AI, these companies would not exist. So one of the thing that this company really got specialized in is the ability to do, using AI and video cameras, being able to profile the people that are passing by, right? Both from, gender, ethnicity, age, and so on, but even most important to more dynamic aspects, such as, for example, their motion in that particular moment. Not just that, but for example, they can also look at if it's a group of people, is it a single person, male, female, is it a couple, right, passing by, or is a family, a couple with maybe some kids. And they can utilize all this very interesting information to be able to select, think about like a bus stop. They have this full-size advertising display. They put small cameras, they are invisible, right? And essentially, if you pass by, they look again at all this information about you, and then use an algorithm, and typically also based on AI, to be able to select what might be the most relevant type of ads to be able to display for you, right? A lot of people nowadays, they often ignore ads, and one of the reasons is that a lot of them they are there, but they're not really relevant to you. So being able to be relevant to the audience in that particular moment, especially in a physical world rather than online, which is easier to do targeted, it's become very, very important. And a lot of advertisers, for them it's very important because people spend a lot of money in advertising and they need to see a return. So these technologies are key for advertisers to be able to demonstrate that the right people are the ones, first of all, passing by their ads, right? So they can demonstrate that by having statistics of the profile of people passing by and the quantity of people, and then again promising that to be able to display particular ads only to the people that this might be relevant to, right? And you can see here, these are real screenshots showing some of the information for each person. They can also look at gaze, right? We have one AI model that looks at where people are looking at, right? And so to see if we caught their attention and for how long we caught their attention, or how long were they looking toward the ads, right? And so that also helps to feedback and capture information. Apart from visualizing to make a decision, it's also a way to capture information, which of course are anonymized. They don't keep the face of anyone, right, or the identification of anyone, but they just use that to profile again also the effectiveness by looking at the gaze of people that ads that were displaying. So just try to be creative and think about, how can this be applied to other things out there. Now, something else add on top of all of this is a technique called HAR, human activity recognition. In this case, we use the LISA model to be able to create a sort of stickman with a person by looking at every single joint. Once we have that, and we have this kind of stickman, then we can use different algorithms to be able to, validate what kind, based on the movement, etc., what kind of activity or what the person was doing. And again, to be able to do experiments on human behavior or just for public safety, being able to, to see, if someone is fighting, be able to detect that in public cameras. We have 100,000 cameras in Singapore. If we want to detect that there's been a fight somewhere, it's going to be very difficult as someone is actually looking at a camera, right? So we do need AI to be able to detect this and then bring it to the attention of someone. An example also in Singapore is that there was a project with a mental hospital to give more freedom to certain patients. And what it would do, it would use the same cameras, CCTV cameras in the building and also into the ground, the park around the building, to monitor. And actually, we're also using drone to monitor the patients, right? By doing facial recognition, they know who they are as well, and being able to monitor that they're not harming themselves. For example, they're not having a seizure, or there's, everything is okay with them, right? And at the same time, being able to give them more freedom, right? Not having someone always overshadowing them, and also, of course, being able to do this with less staff, human people to have there to, to monitor this, which is expensive. And also, we have to remember that people's, attention span and accuracy is actually a lot lower than AI. I also want to touch briefly on, and I apologize if I have to rush, but if I want to touch on cybersecurity, that's another big area. If you look at law, AI is being utilized in fighting crime, both online and offline. And nowadays, the topic of intellectual property, on how to protect it, and how to use AI to protect it, is very big. An example is the fact that we are using movie companies are using AI to automatically scan the internet, find videos, ensure that the video is something that is protected by their copyright, and being able to even auto-generate letters to send to the hosting site to get them to ask them to take it down, right? And a lot of this technology is actually being developed now by specialized law firms who do this, as a service. Cybersecurity, also very important. We have more and more system, more and more data in network. So again, being able to detect, something is wrong becomes even more difficult. That's where really GPUs, everything I'm talking so far, GPUs are really key, and high performance computing is key, because every single task to do with AI or large volume of data, such as in cybersecurity, really requires a high level of computation, right? Otherwise, it would be impossible to do any of these things I'm describing. And in cybersecurity, we have a number of techniques that utilize both statistics and just pure big data processing, together also with specific machine learning and deep learning methods to be able to detect APT and also to analyze, in real time, large volume of logs. What is interesting is that a number of commercial companies also have come up, been specialized in this. Graphistry is a particular one that's very interesting. And one of the many things that they do, and you can see here, the CM and the ability to do essentially combine different type of threads into a single system. We can see here that Graphistry, I'm gonna, yeah, here it is, generates very beautiful visualization that allows people to better understand either as a postmortem or in real time how, in particular in network or in system, how things are being interconnected. And then of course also utilize AI to see correlation. In APT is very key to understand, for example, what's going wrong. Another key technique also used in cybersecurity with AI is essentially anomaly detection, right? In AI, you can utilize a system to learn by itself what would be normal, and then being able to just understand that something is abnormal in a heuristic fashion, while they will not be 100% sure of what it means. They are able to learn by themselves that something is just abnormal. And finally, I just want to touch also on FSI. FSI, again, is an industry that both when it comes to high performance computing and also now AI has been one of the biggest user. They have to crunch a lot on numbers, do a lot of math, be accurate and be able to do that as fast as possible to be competitive. Think about algo trading or risk analytics or other techniques. And it's really important for them to have all these kind of resources available. So one of the things I'm going to talk more about is going to be customer service, right? Especially today with COVID and auto branches are closed. How to be able to do better customer service and more efficiently, but with lower resources, human resources and also lower cost. And that, of course, requires you to make take full advantage of a lot of different tools. Now, of course, when it comes to HPC and AI, there is quite a lot of techniques out there in areas in FSI that is being taken advantage of. So clearly there is capital markets, predicting how the market will go, the management of payments, fraud, and detecting fraud is a very big one, but also, in insurance and in risk prediction. So in payments, we have quite a lot of companies nowadays, even in Southeast Asia, from Grab to Garena and the C Group, and also Vietnam. There's quite a lot. There is a lot of companies coming up with alternative payment technologies, right? And being able to guarantee security and have intelligent analytics for them is really important. And a lot of them are using AI to be able to achieve this. So this is what it looks like, and you are going to get a copy of these slides, so don't worry. But on how we develop a fraud detection model using AI. Now, it's very important. Credit card fraud, debit card fraud, and also anti-money laundering legislation. All of this has to be enforced. At the same time, you can think from a credit card or even a instant payment company perspective. Definitely they want maximum security and minimum fraud, but at the same time they definitely don't want any false negative, right? They don't want to stop transactions that are legitimate. And the ability to do that, has been made by moving from more traditional machine learning and more static models into more dynamic deep learning and AI-based model that constantly learn from data and constantly learn based on the customer profile and also the customer past, right? To be able to really, combine all of this data together to be as efficient as possible. So AI is really key in all of this. And this is some of the tools, such as Rapids, which is a open source framework that runs on top of Spark, and also Graph Analytics using QGraph. All of these are open source and free libraries that we make available to accelerate all of these tasks on GPU. In the past, many of them would have required very, very large clusters, but now, with a lot less resources just using GPU, you can run very, very large simulation and model trainings that it was unthinkable before. And I think later, they will share NSCC about also the GPU resources they have in their multiple clusters. So I'm just going to skip on this, but I just show you essentially how the accuracy using deep learning versus more classical models or random prediction, or even the handcrafted ones can provide inaccuracy of fraud. Now, going to, quickly on the customer service, very, very key, in particular in retail banking, right? And there's a very large number of AI-based technologies that can be used to be able to do this, from recommending products to be able to have a more interactive chatbot and call center services. One example that you might have already seen in Singapore is the ability for us to authenticate on telephone banking using our own voice, be able to use voice recognition, a lot easier than remembering PIN and passwords, to be able to safely authenticate oneself just by calling your bank. And also OCR, another very key technology when we interact in particular with apps, is eKYC, which is know your own customer. And it can be from an app, being able to take a picture of your own ID document, which will be automatically scanned to do OCR on the text, and also to do face recognition on the picture to authenticate that is yourself, to again automate a lot of these authentication tasks that would have to be done manually in the past, right? And now they can just take a few seconds. There is, of course, a lot more chatbot and intelligence that comes from the call center to again be able to give the best experience. But one important use cases I saw. Yeah, I've got only this is the last slide. It's the last slide, I promise. One of the most important one is insurance claims. I had a big project in Malaysia in which one of the issues they had, and also this is correlated to the the ringgit being quite low, is the fact that their biggest problem was the overhead of cost in processing small claims, right? So they were the cost of processing claims of small value was too high, correlating it to the value of the claim. And so being able to automate it as much as possible was key. So for those small value claim, they use AI, and they're able to analyze the text using natural language processing. And also they're able to analyze the picture of the damage and be able to automatically assess if the quote that they received matches the type of damage that they detected, and also be able to detect, of course, suspicious claims as well, right? So there is a lot of interesting and very advanced technology that can help with all of this. Last slide is just saying that we have also smart cities, something that really AI can help a lot in a variety of use cases, to be able to have a more smooth experience for a population. And a lot to do with that is to do with human behavior, analyzing it, be able to forecast situation, and be very preventative and proactive in the management of any resource out there. And all of this really can only be achieved using AI and high performance computing. So it's really key that you understand the importance of computational resources in order to achieve any of these very, very interesting techniques and use cases out there. And with that, I'm done and pass it back to NSCC. Sorry for the rush.
Thank you, Nicolas. Now we have Jia Xing from NSCC, where she will share more about the call for the next education projects. Jia Xing, please.
Hi, yes. Okay, so let me share on the call for projects in NSCC. For our call for educational project, this is a new call just launched in May this year. And the next upcoming call, you all can look out for the application period in October for resources from February to January. This will be a bi-yearly call, and we are extending the supercomputing resources to the local research and IHLs. You can actually use these resources for educational purposes, such as supporting lab exercises, teaching modules and project-based modules, competitions and workshops and the likes. And these applications will be reviewed by our committee, comprising of the representatives from individual IHLs. And this call will be open to all universities and polytechnics. So you can look out for the announcement for the application soon. And next, we have this call for COVID project. The first phase will be closing on the 23rd of September, which is today. And if you are interested, you can apply. You get priority in the job submission, and this is open to everyone. However, no worries that we are planning on an extension for a second phase. So you can look out for the announcements as well. And that's all for my presentation. Thank you.
Okay, thank you so much, Jiaxing. Everyone, thank you so much for your patience and your time. Just want to summarize a few things. One is that, as you all can see, there is lots of resources and talents that you can rely on your ecosystem, from NSCC to AISG to NUS researchers, IHPC researchers, you know, lots of talent, including industry people like NVIDIA and MSc Hexagon as well. So do leverage on it. I just want to quickly close off a few things. One is obviously the slides will be shared with everyone. Two is that do go and set up a trial account. And if you want to if you want to get in touch with the speakers and researchers about your projects or your concept, we'll be more than happy to facilitate. And that will then lead to your call for project. I'm more than happy to do so. Okay. I really thank you all for all your time today. I know it has been a long session, but I hope you find this very useful, and definitely look forward to collaborating with all of you for the future. Look out for our emails to download the slides, as well as the next step on our journey to help you digitalize and enable your schools and your students itself. All right. If not, thank you, everyone. Have a nice lunch.